Let's go now to our second topic for this lesson, which is finding the angles of a triangle. We have triangle properties as follows. First, in a triangle, the sum of all of the measures of all three angles is 180 degrees. The sum of the measures of all three angles is 180 degrees. Remember that sum means you're adding them. So adding the measures of all three angles, you will get 180 degrees. I've sketched a triangle here. And I have a protractor. The protractor is a device for measuring angles. In the protractor, we have a starting place. It's here in the center of the bottom of the protractor. You see where the two lines come together? This is our starting place. When we measure an angle with a protractor, we put that starting place at the vertex of the angle, which is where the two sides of the angle come together. So let's begin by taking our protractor and measuring this angle right here. I'll put the protractor so that that starting place is right at the edge of that vertex. Now I could tilt this in all kinds of ways, but I want my zero line, this line on the protractor, which in some devices, some protractors, is right at the very bottom, but in this one we have a little bit of play to work with, so it's up a bit. The zero must be lined up on one of the sides. So I'll line it up just as best I possibly can on that side. We then can read the measure of the angle by looking at where the angle crosses the measuring values on the protractor. So we read it from these numbers. Now notice that on this protractor we have two sets of numbers. I mentioned that we're starting with a 0 here. Well, notice that 0, 10 would come next in that part, 20, 30, 40, and so on. That's the inner ring of numbers. We're going to use that one for this angle because our 0 is lined up on one side of the angle. All right, and then we'll measure directly through where this other side comes through the measuring numbers of the protractor, and the number in this lower band is 60. Now this means that the angle that we're measuring here is 60 degrees. So that is 60 degrees. Let's measure the other angle at the bottom of this triangle, this one. I must put the cross places for this one. Let me get that glare off of our screen. I must put the cross places at the vertex of the angle. So in this case, I'm measuring toward the other side of the protractor, here to the left of the protractor. Let's find the 0 on the left-hand side. Let me move it up so we can read the numbers. Notice that 0 on the left-hand side is on this outer band. I've always got to start with a 0, so I'll measure on the outer band of numbers. So, lining it up the very best I can, I have the line of this angle crossing the protractor at, well, there's 10, 20, 30, 35 would be this mark. It looks like 36 degrees. 36 degrees. So this one is 36 degrees. Now I want to measure the other angle. So I have the luxury of having a sheet of paper that this is drawn on, so I can turn it around. If I didn't have that luxury, I could just line up the protractor, turning it in such a way that the vertex of the angle matches with the 0, the starting point on my protractor. Well, maybe I can just do it that way. That's probably easier for you to keep up with. So let me do that. So I'll line up my bottom line of the protractor on one side of the triangle with the numbers inside that angle. And let's see which side of the numbers has the 0. My fingers are in the way for most of them, so let me slide it up here and we'll take a look. The 0, here's the 0, 10, 20, 30. 0 is the inner number there. So let's see, line it up again. There we go. So that the crosshairs, as it were, on the vertex, the 0 is lined up on there. I'm using the inner values, and I get here's 70, 80, 1, 2, 3, 4, 84 degrees. So this third angle is 84 degrees. Now, according to the rule that we have, this property of triangles, the sum of these three angles should be 180 degrees. Well, we have 84 degrees, 60 degrees, and 36 degrees. 4 plus 6 is 10. Carry 1. 9 plus 6 is 15, plus 3 is 18. 180 degrees. So here they are. 60 degrees, 84 degrees, and 36 degrees for this particular triangle. Let's look at another property for triangles, and it says, in an isosceles triangle, the angles opposite the equal sides have equal measures. Well, let me measure the three sides of this triangle. I hope I have drawn an isosceles triangle. Let's see whether I have. All right, if we're measuring, that looks like about 8.5 centimeters. And this one, 6.5 centimeters. Notice that so far these two are not the same size. And then this one I hope is going to match one of those. Ah, there we are, 6.5 centimeters. So these are the equal sides, this one and this one. The angles opposite those, the angle opposite this one is the angle that doesn't use this as one of its sides. So it's over here, this angle. And the angle opposite this one is the one that doesn't use it as one of the, it doesn't use this side as one of the sides of the angle, so it's over here. So we go in the opposite corners, and let's take our protractor and measure those two angles. We have, lining up the 0 there, 10, 20, 30, 40, 50 degrees for this one. And putting the 0 on the bottom line and the crosshairs at the vertex. This time we're measuring the outer numbers because we're on the 0 is at this point, 10, 20, 30, 40, 50 degrees for that one. And so the angles opposite the equal sides of that isosceles triangle have equal measures. Now we want to use our first property in solving problems, and we're almost ready, but we've got one more definition to come. Here it is. A right triangle is a triangle in which one angle measures 90 degrees. A right triangle is a triangle in which one angle measures 90 degrees. Notice that the protractor has, here's a 0 or here's a 0 depending on which side you're working from. Either way, when we get to the very top, we get the 90 degrees. 10, 20, 30, on the inner, 10, 20, 30, 40, 50, 60, 70, 80, 90. And on the outer, measuring from the other side, we go up to 90. 90 degrees would be a nice square corner.